Okay. So you guys should have completed transformations that map figures onto itself, quadrilateral section. You should have done um, these four questions related to identifying polygons. And if you don't know the shapes, you need to create a study guide that breaks down which shape is which, like a hexagon, 6 sides, an octagon, 8 sides. So you need to create a little study guide or cheat sheet for yourself that involves all of those vocabulary words. Um, and at some point we'll do that in class too, but you should definitely take initiative and do that yourself. So we're going to get ahead into this question, check for understanding number one. And you should be watching the video before doing this, right? So there's a Desmos activity, and I'll post this on Google Classroom as well, that kind of goes through the idea of rotating a shape onto itself. So with this situation, obviously this is a triangle. Hypothetically, if we were to rotate this triangle, notice how if I rotate it, let's say 60 degrees, it doesn't look or it's not in the same position as it was with the black triangle. So it obviously turned. But if I rotate it some more and some more and some more, notice where it lands on itself at. It lands on itself at 120 degrees. But why? So let's talk about the why part for a second. So I'm gonna walk you through that. So imagine you imagine this is the center of the triangle. And it is, but let's say if you didn't know, like you could just pretend that it is for now. I'm going to draw a line from the vertex here to the center. And it doesn't have to be a perfect line, but and I'm going to draw a line from this vertex to this center. And I'm going to draw a line from this vertex to this center. Notice we have three angles on the inside. We have this angle, we have this angle, and we have this angle. And I'll put them in a different color just so that you could know that this is one angle and this is another angle. And then there's the other purple angle. So this little arc indicates, or this space right here indicates this angle, and that pink space is the other angle, and then that angle. Notice, and although I know it's not perfect, if you go around these three angles, it's a circle. So this is a circle, y'all, right? So each of these angles, this angle, and this angle, and that angle, all of these angles combined will give you the measure of 360. Well, how do we find these individual angles then? I want to know what each angle is. Well, it's three angles, and since it's an equilateral triangle, you could divide this by 3. So 360 divided by 3 is 120. And that's how we arrive at this number. That's really what we're doing. And what's happening, 3 represents the number of sides. And whenever you have a question like this, you're going to be doing this. You're going to divide 360 by the number of sides. So for this particular question, that is the answer. What is the minimum number of degrees needed to rotate an equilateral triangle onto itself? As you notice, when I did 120, it worked. But when I did, let's say 90 or 100, it didn't work, right? So 120 or 105, pardon me. So 120 was the smallest angle of rotation. You could keep going and then notice when it lands on itself again is 240. So it like 120, 240. You should realize that the next one would be another 120 degrees, which is 360. So that is pretty much it for this question. I would like for you to do the same thing, but for a pentagon. a pentagon, you should realize, has 5 sides. So in the Desmos activity, you're going to change this to 5, and you can, determine what it is. But again, you need to know this formula, and please write this down. 360 is going to be divided by the number of sides. And this is going to give us the minimum let me just, it just glitched, but that's going to give us the minimum number of degrees needed to rotate the shape onto itself. All right, so if you're listening, obviously, please transcribe that in words and make it work for you. And then the same thing for this, you're going to write you're going to fill in the blanks to find the angle of rotation or the minimum number of degrees. What are you going to do? What did we do in the formula, right? And then you're going to pick one of these, and then you're going to work on these questions, all right? Again, if you're not sure about like the sides and stuff like that, like a dodecagon, you could always look it up in Google, right? Like dodecagon. And it'll tell you how many sides a dodecagon has. So please just look it up if you're unsure, but please don't just try to Google the answer, obviously. Try to understand it. And if you need to look at a video, look at a video. Or watch the example or whatever the case may be. All right. Thank you guys for watching. Have a good day, and please stay focused and continue to put in the work and the energy needed to be successful. Have a good day.